Fire hydrants are essential to every community. They need to be instantly recognizable, easily accessible, and simple to operate. The ones in residential areas are designed to deliver no less than an impressive 5,700 liters per minute. The hydrant making process starts with recycled scrap iron, along with steel and raw iron. Using a magnetic crane, workers load the metals into a furnace and melt them at 1,538 degrees Celsius. This turns the scrap metal into molten iron. Then they transfer the molten iron into a remote-controlled ladle and empty it into an automated pouring system. To cast the hydrants, workers first make two-part molds by compressing a mixture of sand and bonding materials. One part, called the mold, forms the hydrant's exterior shape, while the other part, called the core, forms the interior shape. An automatic core setter positions a core in each mold. Then a conveyor advances the mold under the pouring box, which fills the cavity between the mold and core with molten iron. After the iron cools and solidifies, the molds enter a tumbling barrel. As they revolve, the sand gradually disintegrates, freeing the iron casting inside. Workers drill and thread the hydrant castings to prepare them for assembly. Then they pre-assemble and paint them the color the customer requested. The fire hydrant's internal workings, called the valve assembly, allow water to flow through when opened. A series of rubber O-rings on the main valve will prevent leaks when the hydrant's closed. Now the hydrant is ready for final assembly. Workers attach the nozzle section to the top of the hydrant barrel and attach nozzle cap chains with a crimping tool. Using a torque wrench, they attach cast iron safety rings. These rings are designed to disengage the top from the bottom of the hydrant so it doesn't get damaged if a vehicle hits it. Workers clamp the water main connector into place and pressurize the hydrant to normal city pressure to check for leaks. Using a hoist, they lower the pre-assembled nozzle section over the stem and fasten it to the water main connector with stainless steel bolts. They lower the bonnet into place, bolt it to the nozzle section, then open the hydrant for a high-pressure test. They turn the operating nut to allow water to flow through. Before conducting this test, they force out the air inside the hydrant with water. Workers transfer the finished hydrant to a pallet and apply final paint touch-ups. Some fire hydrants that were installed more than 100 years ago are still in use today.
Fire protection for your city is only as good as the equipment used by your firefighters. With the extensive loss of life and property to fires each year, it makes sense to provide them with the best equipment available. For over 60 years, the M&H Style 129 fire hydrant has met the rigorous demands of the firefighting industry. Fire departments throughout the country rely on the quality and dependability of hydrants and valves provided by M&H Valve Company. This video will describe the features of the Style 129 hydrant. Then the procedure for removing and reassembling the hydrant internal parts will be demonstrated. And finally, the steps to extend the hydrant will be shown. The Style 129 fire hydrant is designed with the end user in mind. It is a dry barrel hydrant featuring ease of installation, operation, and field maintenance. Not only have our engineers continuously upgraded the 129 to ensure reliable operation in critical situations, we also have maintained parts interchangeability between today's hydrants and those produced over 60 years ago. The ability to retrofit older hydrants ensures complete compatibility for all of your M&H systems, past, present, and future. Designed and manufactured at our facility in Anniston, Alabama, we combine engineering expertise with state-of-the-art production capabilities to ensure all hydrants are made efficiently with optimal product quality. Iron parts are made with either high-strength cast iron in compliance with ASTM A126 Class B, or for ductile iron parts, ASTM 53670-50-5. After proper smelting, the iron is formed with automatic molding machines to ensure the highest level of uniformity. Parts are then machined to precise tolerances. The 129 is designed to fully comply with WWWL2 standards for dry barrel hydrants. All hydrants are seat tested to 250 psi and shell tested to 500 psi. The bonnet design features a unique single unit component with an integral lubrication chamber that isolates the stem threads from dirt and moisture. The tamper-resistant operating nut serves to prevent moisture and dust exposure to the bronze stem and provides protection against freezing conditions for smooth operation in cold weather. A nylon anti-friction thrust washer reduces operating torque to facilitate opening and closing cycles of the hydrant. The 129's dual lubrication system enables the use of either grease or oil as the operating mechanism lubricant. Lubrication is provided in the factory and can be added in the field by removing the weather shield hold-down bolt and weather shield and lubricating through the bolt hole at the top of the operating nut. The lubricant is contained in the chamber by two O-rings that prevent water from entering when operating under pressure. The upper assembly section utilizes a high-strength steel stem encased in a brass stem sleeve that provides a smooth, non-corrodable bearing surface to ensure efficient, durable operation. Additional leakage protection is provided by an O-ring seal between the stem and sleeve. The 129 hydrant can be provided with two hose and one pumper nozzle, or with just two hose nozzles. For national standards, the hose nozzle is 2 1/2 inches diameter, and the pumper nozzle is 4 1/2 inches diameter. Special sizes and materials are also available. Made with high-quality brass, the hose and pumper nozzles are machine threaded into nozzle outlets that are easily removed for field replacement. Designed to ensure high flow capacity, the compression-type main valve is available in 4 1/2 inch and 5 1/4 inch sizes. The valve opens against water pressure and is held shut by this pressure during repair, maintenance, or impact. Two bronze bushed drain valves provide quick drainage of the hydrant to prevent freeze-ups that could occur if water were left standing in the system. The drains are self-flushing with each cycle of the main valve. All internal working parts, including the main valve, are easily removed through the top of the hydrant without costly excavation. To improve nozzle alignment, the above-ground hydrant can easily be rotated a full 360 degrees. Simply loosen the flange bolts, rotate the hydrant, and retighten the bolts. Fabricated for extra strength, the ductile iron standpipe supports the hydrant below ground level. The hydrant shoe is made of similar high-strength material and in accordance with WWWL2 features fusion-bonded epoxy-coated ID and OD. M&H engineers designed a split safety flange connection at the ground line. At impact, the safety flange connection breaks and the stem coupling separates. This enables above-ground assembly to cleanly separate from the standpipe without damage to operating components. M&H provides the traffic repair kit to easily restore the hydrant to service. Simply replace the coupling on the stem, install the new safety flange connection to the nozzle section flange, and reassemble the hydrant. M&H also provides the hydrant disassembly wrench, a pumper wrench, the main valve repair kit, a spanner wrench, and an extension kit that will be demonstrated later. Removing and reassembling the internal parts. First, stop the flow of water to the hydrant by closing the auxiliary valve. Then remove one of the hose caps and partially open the hydrant to ensure water is not flowing into the hydrant. Remove the weather shield hold-down bolt and weather shield. Then remove the set screw to the hold-down nut. Remove the hold-down nut with a spanner wrench by turning clockwise on open left hydrants and counterclockwise on open right hydrants. Now remove the operating nut and thrust washer by turning the nut counterclockwise on open left hydrants and clockwise on open right hydrants. After removing the bonnet nuts and bolts, the bonnet can be removed from the nozzle section. Remove the bonnet O-ring. Lower the hydrant disassembly wrench over the stem until the slots are engaged with the coupling and turn counterclockwise to separate the stem valve assembly from the bronze seat ring in the hydrant shoe. When disengaged, remove the stem valve assembly by pulling up through the nozzle section. Secure the stem valve assembly on a hard surface using a vise or a pipe wrench. Remove the lower valve plate by turning counterclockwise. Now remove the lock washer and the main valve rubber. Remove and inspect the main valve seat. Check the O-rings and drain valve facings and replace if necessary. Arrange the top plate and main valve seat in the closed position. Affix the main valve rubber and the lock washer. Attach the lower valve plate and tighten to 300 foot-pounds torque. Lubricate the O-rings and threads on the main valve seat. Lower the stem valve assembly into the hydrant and slowly rotate the assembly counterclockwise until the threads are engaged. After the threads are engaged, rotate the assembly clockwise until securely tightened with a torque between 100 and 150 foot-pounds. Replace and lubricate the bonnet O-ring. Inspect the O-rings in the neck of the bonnet and replace if necessary. Slide the bonnet over the upper stem and attach the nuts and bolts. The nuts and bolts should not be firmly tightened until the complete unit is assembled. Lubricate the operating nut through the hole on the bottom side and place the thrust washer on the top side. Now screw the operating nut onto the upper stem. Check the condition of the weatherproofing O-ring in the hold-down nut. Slide the hold-down nut over the operating nut and tighten to 100 foot-pounds torque. Replace the set screw. Reassemble the weather shield and weather shield hold-down bolt and tighten to a torque of 25 foot-pounds. Then tighten the bonnet nuts and bolts evenly to a minimum torque of 75 foot-pounds. Replace the hose nozzle cap, leaving it slightly loose. Open and close the hydrant to make sure that it operates smoothly and easily. With the hydrant in the closed position, open the auxiliary valve to start water flowing to the hydrant. Now completely open the hydrant. When the water starts flowing, tighten the hose nozzle cap and inspect all of the joints for leaks. If no leakage is noted, close the hydrant completely. The hydrant is ready to operate. Extending the hydrant. Before beginning this procedure, examine the extension kit to ensure you have all of the required parts. You should have 8 flange nuts and bolts, 2 flange O-rings, 2 retaining pins, 2 clevis pins, 2 extension flanges, 1 extension coupling, 1 extension stem, and 1 barrel extension. Although the hydrant can be extended while water is flowing, we strongly recommend closing the auxiliary valve whenever you work on the hydrant. After ensuring water is not flowing into the hydrant, remove the weather shield hold-down bolt and weather shield. Then remove the set screw to the hold-down nut. Remove the hold-down nut with a spanner wrench by turning clockwise on open left hydrants and counterclockwise on open right hydrants. Now remove the operating nut and thrust washer by turning the nut counterclockwise on open left hydrants and clockwise on open right hydrants. After removing the bonnet nuts and bolts, the bonnet can be removed from the nozzle section. Remove the bonnet O-ring. Then remove the safety flange nuts and bolts and the safety flanges. Lift the nozzle section over the upper stem and place to the side. Remove the O-ring from base of the nozzle section. Remove the upper stem by removing the retaining pin and clevis pin. Be careful not to drop any of the parts into the hydrant. Clean the sealing surface of the standpipe. Then attach the extension coupling to the extension stem. Next, connect the extension stem to the lower stem coupling. Place the O-ring on the extension barrel. Lower the barrel extension carefully onto the standpipe. Make sure the extension is concentric with the standpipe flange. Secure the extension to the standpipe flange with the non-breakable extension flanges. Tighten evenly to a minimum torque of 75 foot-pounds. Then attach the upper stem to the extension stem coupling and replace the retaining pin and clevis pin. Clean the sealing surface of the nozzle section and replace the O-ring. Now lower the section carefully onto the barrel extension. Ensure that the nozzle section is concentric with the barrel extension flange and that the nozzles are oriented in the correct direction. Bolt the two safety flanges in place using the existing nuts and bolts. Flanges should fit securely around the barrel. Tighten the nuts and bolts to a minimum torque of 75 foot-pounds. Replace and lubricate the bonnet O-ring. Inspect the O-rings in the neck of the bonnet and replace if necessary. Slide the bonnet over the upper stem and attach the nuts and bolts. The nuts and bolts should not be firmly tightened until the complete unit is assembled. Lubricate the operating nut through the hole on the bottom side and place the thrust washer on the top side. Now screw the operating nut onto the upper stem. Check the condition of the weatherproofing O-ring in the hold-down nut. Slide the hold-down nut over the operating nut and tighten to 100 foot-pounds torque. Replace the set screw. Reassemble the weather shield and weather shield hold-down bolt and tighten to a torque of 25 foot-pounds. Then tighten the bonnet nuts and bolts evenly to a minimum torque of 75 foot-pounds. Open and close the hydrant to make sure that it operates smoothly and easily. With the hydrant in the closed position, open the auxiliary valve to start water flowing to the hydrant. Then slightly loosen one hose cap to bleed out any air. Now completely open the hydrant. When the water starts flowing, tighten the hose nozzle cap and inspect all of the joints for leaks. If no leakage is noted, close the hydrant completely. This completes the procedure for extending the 129.